Hey guys, this is a video on Unit 6, Topic 4, proving triangles are similar by SAS and side, side, side. So I'm in the Topic 4 packet. Make sure you're on the one that says SAS and SSS and not the angle packet. And I'm going to take a look at number 8. Number 8 asks me to prove that I have parallel line segments, and I'm going to start by proving that the triangles are similar. So I'm going to start by writing my similarity statement. I'm going to pick one of my triangles, JLK, similar to triangle. Now the whole idea is that if these segments are parallel, then I dilated this smaller triangle to get this larger triangle. L went to N and K went to M, and J is my center of dilation because it didn't move. So J corresponds with J, L corresponds with N, and K corresponds with M. I'm just going to go ahead and make my list of congruent angles. And number them. I'm going to label them in the diagram. And I'm also going to write my sides that are in proportion, so my equal scale factors. Again, you don't know which triangle is new and which is old. It doesn't matter. You get to choose as long as you're consistent. So I just usually choose the first one to be new and the second one to be old. Okay, so I've got my setup done. I'm ready to start my proof. Now, looking at the givens, this is clearly not an angle-angle proof. I gave you side lengths, so not angle-angle. It's either SAS or SSS. And to determine which of the two it is, I just have to count them. If I gave you 1, 2, 3, only 4 lengths, I can't use side-side-side similarity. For side-side-side similarity, I need to prove 1, 2, all 3 scale factors are equal, in which case I would need 1, 2, 3, 4, 5, 6 side lengths. I don't have 6, so this is going to be a side angle side similarity proof. So starting with my first given, JK equals 4, KM equals 6, JL equals 5, LN equals 7.5. And at the same time, I'm going to label them in my diagram. And then I'm going to use the scale factors that I set up to start substituting in values. I'm not going to rewrite them. I don't have to. They're right here. I'm just going to start substituting. So checking JL, I know this length, it's 5, over the length of JN, which I didn't give you, but we can certainly find. We get 12.5 if we add those two parts together. So the length of JN is 12.5. And we're going to check to see if it's equal to, let's see, LK and NM I don't know anything about, so I'm not going to use the scale factor. And then KJ is 4, and MJ, again, I just have to add those together. I'm going to get 10. Okay. And the next step is to use my calculator to check to see that those are actually equal scale factors. So I'm just going to type them in. 5 divided by 12.5. And it gives me a decimal because my 12.5 is a decimal, so I'm just going to hit menu. Hold on. I'm going to go up and grab it and bring it down. I'm going to hit menu, 2, enter, and it tells me that it's equal to 2/5. So this one equals 2/5, and then I'm going to type in 4 divided by 10, and that one is also equal to 2/5. So my scale factors are equal. If my scale factors are equal, that tells me my corresponding sides are in proportion. And so my conclusion is to say which sides are in proportion. So my conclusion always comes from my list, okay? Which of these two scale factors did I use? I used JL over JN. That was my 5 over 12.5. and I used KJ over MJ. That was my 4 over 10. So I just proved that these were equal scale factors and that my sides were in proportion. So right now I only have 2 sides crossed off my list. I can't, again, get this third side because I don't have any more lengths, so I need to find an angle. Again, if you're going to use side angle side, you have to make sure your angle is between your 2 sides. And highlighting can be helpful. So if I, for example, use side JL in the smaller triangle and side JK in the smaller triangle, my only option for angles right now is that angle between, that angle 5 and 6. And those we know are congruent by the reflexive property. So step 2, reflexive property says an angle is congruent to itself. So conclusion, angle 5 is congruent to angle 6. Cross it off your list. It's already marked in the diagram. Those are your 3 items, 1, 2, 3. So we're ready to say that the triangles are similar. And again, I'm getting my similarity statement from right here. By side, angle, side, similarity. I'm not done. I still need to prove that my lines are parallel. The way that I prove lines are parallel is by getting angles congruent. If, for example, alternate interior angles are congruent, my lines are parallel. If corresponding angles are congruent, my lines are parallel. So looking at this diagram, hopefully we see that angles 1 and 2 are corresponding angles. Also, 3 and 4 are corresponding angles. I can use either of those 2 pairs of angles. I don't need both of them. And now the reason that I know that they're congruent is because I proved the angles were similar, the triangles were similar, and I know in similar triangles, corresponding angles are congruent. So my next step is to say if triangles are similar, then corresponding angles, don't write parts, it's just angles, are congruent. So my conclusion, again, you can use 1 and 2 or you can use 3 and 4. I'll use 1 and 2. Those are congruent angles. So last step, if I prove that corresponding angles are congruent, then I know that I have parallel lines. Again, that's from September, that's from Unit 1. So conclusion is my prove line. I'm going to say that my line segments are parallel. Segment LK parallel to NM. And we're done.